Hello there, this is codingpros.in, and today we'll be talking about time complexity and we'll get a intuitive understanding of what time complexity is and what the big O notation is. Okay. So what is time complexity? So sometimes when we write programs, there are more than one way to solve a problem. And obviously there are more than one ways to write algorithms for that. And we need to learn how to compare the performance of different algorithms, whether one algorithm is better than the other, or which one should we choose, things like that. Okay. So while analyzing an algorithm, we mostly consider time complexity and space complexity. So time complexity of an algorithm quantifies as the amount of time taken by an algorithm to run as a function of the input size n. Okay. So, and similarly, space complexity quantifies the amount of space taken by an algorithm to run as a function of length of the input size. So this is what time complexity and space complexity. But let's go over a intuitive understanding of what time complexity is. Suppose there are three students in a class and I want to ask someone if he has a pen or not. So I basically need a pen. So I define this operation of asking, do you have a pen, as one operation, and this would cost 1 unit of time. And for the sake of simplicity, let's say 1 unit of time means 1 minute here. Okay. So, and also let's assume that the class for which I'm asking the pen runs for 45 minutes. So there's a computer science class going on and I don't have a pen and I want pen. Cool. So what do? I go to the first student and ask him, hey, do you have a pen? And also let's define this operation as x, because I would not have to write do you have a pen again and again. Okay, so I go to one and I ask, hey, do you have a pen? He says, well, I don't know. Okay, I go to one and ask him, hey, does two have a pen? He says, well, I don't know if two has a pen or not. I go to one again and I ask him, hey, does three have a pen? He says, well, I don't know if three has a pen or not. Cool. So I'm done asking one. Next, I go to two and ask him, just to reconfirm, hey dude, do you know if one has a pen or not? He says, well, I don't know if he has a pen or not. I go to two again and ask him, dude, do you have a pen? He says, well, I don't have a pen. Then I go ask two again, hey, do you think three would have a pen? He says, well, I don't know. Cool enough. Next, we go to the third student and ask him, hey, do you know if one has a pen or not? Just to confirm. He says, well, I don't know, dude. Then we ask three again, hey, do you know if two has a pen? He says, well, I don't know if two has a pen or not. Then I ask three, hey, dude, forget about others. Do you have a pen? And now three says, yes, I do have a pen. So we get our pen asking three. But in this process, in this approach, we had 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we performed 9 operations. Okay, we performed 9 operations to find the pen, and this took us 9 minutes, because as we have defined here, one operation takes 1 unit of time and 1 unit of time in this example is 1 minute. Cool. So this is our first approach, or let's call it the first algorithm that we would go with. So this, I'm calling this as A1, which would be going to each student and asking about every other student. Let's consider the same example again. I have 3 students, and this time let me say this is algorithm 2, and I'm going to the first student. I'm asking, hey dude, do you have a pen? He says, well, I don't have a pen. And this time I don't ask him about others. I simply move on to the second student. And I ask him, hey, do you have a pen? He says, well, dude, I don't have a pen. Now I go to the third student and ask him, hey dude, do you have a pen? He says, well, I have a pen. This approach took us 3 minutes, which is like 3 operations, asking each one individually, which is 3 minutes. Cool. So this also worked for us. This also worked for us. But consider, in a class of 45 minutes, if I had not 3 but 100 students, okay, this first approach, A1, would take us 100 into 100 minutes, and this would take us 100 minutes. Okay, so obviously this approach looks better. Obviously it doesn't solve our problem of completing the uh, pen fetch in 45 minutes, but yeah, it is much better than this algorithm. So even if we had a class of around 50 students, 1 to up to 50, this would only take us 50 minutes to reach to the solution, but this algorithm would take us 50 into 50. So why I'm saying that, consider you had 4 and 5 also here. So you would ask 1 about 4, you would ask 1 about 5 here, 2 about 4, 2 about 5, and this would basically be the square of the number of people. Okay, so now let's consider this one. So we use big O notation to define the complexity as a function of input size. Okay, so the first algorithm took us n square time, and the second algorithm took us n time, which means as the number increases, our time would linearly increase. For 5 people it would take 5 minutes, for 3 people it would take 3 minutes, for 100 people it will take 100 minutes. Cool. But in this particular case, the complexity was n square, because for 3 people it took 9 minutes, for 5 people it would take 25 minutes, for 10 people it will take 100 minutes, and for obviously 100 people it will take 10 power 4 minutes. So this is the time, this is n, so this complexity is O of n square. Okay, so now let me take one last example, which is our third algorithm. Suppose in a class of 500 students, n is equal to 500. Okay, let me take a smaller example first, so that it's better to explain. So suppose n is equal to 5, I have 5 people here. Now I know that this third student is my crush, or my girlfriend, or my future girlfriend. Just for example, that's never gonna happen because I'm so single, but anyway, next. So even if I have these 5 students and she always has a pen, Cool. Now, even if I have 5 students, but I know that, hey, my crush always has a pen, I'm just going to ask her, hey, dude, just do you have a pen? She says, of course, why not? And she gives me a pen. So this took me 1 minute and only one operation. Irrespective of the number of students in the class, even if I have 500 students, I always go to her, get the pen in 1 minute. So an algorithm like that would have a constant time complexity, which we define as O of 1. Cool, which means it always takes 1 unit of time. And in programming, we try to reduce the approach to O of 1. I mean, that's sometimes not possible, and maybe that's rarely possible, but yeah, we try to get here, or at least we try to get here O of n or O of log n. So more about log n later, but this is the basic intuition of time complexity. Okay, asking each student about every other student took us O of n square. Asking each student individually took us O of n, and just asking my girlfriend took me constant time, which is O of 1. I'm sorry, not my girlfriend, my crush. Cool. Thank you for watching, and if you have any questions, feel free to let me know in the comments, and have a good day. Bye bye.